So to start, you just have to do a pip install. I'm going to use a trace U to update if you already have it. Hermione trace ML. So it's on PP. You can install it from there. Today, Hermione is built on top of Conda. So you have to have an Conda Python or at least mini Conda Python, because we made the decision to use Conda envs and not PyEnvs or regular virtual environments. So there are already people talking about that and asking, oh, so what if I want to do what if I want to use PyEnv or something different? So three things. You can just ignore it and implement and build up a PyEnv and work on top of it. Or you can adjust and use Conda, but that's not the point. We do not want you to adjust to Hermione. We want Hermione to adjust to you. Or you can help us build another integration and contribute in GitHub. Anyway, so it's already here. When it's installed, I do Hermione info to check if it's installed. So we have a nice little logo here with the version. We are 0.1.4 right now. And then we're going to create a new project. So I'm going to create Hermione new to create a new project. Let's call it my ML demo. Okay, so when I hit enter, Hermione will ask me if I want to implement a brand new project or an implemented one, so I can have an example. I'm gonna show you the not implemented one, but I have one implemented one. I have one implemented one to show you, just reach it should be done very. This should not be long to build. Okay, so that's it. And it shows you how do you activate the Conda env that was created for you. So we're gonna do it. Conda activate home Neylson. I'm gonna do my ML demo, my ML demo.env. So now I am in our Conda env. Okay. So I'm gonna change to this new directory that we just did. My ML demo. So this is the project that was built right now. So this is the structure. We have a data folder here with a raw folder. There's nothing here yet. We have the Conda env, the Conda environment here. We have the output folder. There's nothing here. We have the requirements. We already put some to you. As a suggestion, you can obviously you would change this. We also have a README project developed by A3 Data. Obviously, it's not A3 Data; it's you. You're going to change that, no? And we have a git ignore with some things that we don't use in Git. And the source folder. We have a folder for an API if you have to build one. The config with config files that has already the project name, the env path, and the files path. If you have to log into something, you can just put it here if you like. Then you have the tests folder. There's a README explaining to you how to do the tests, in which folder you have to be and stuff. And a structure for you. This just tests if the project was built correctly, and then you have to develop your tests. Then you have some helper functions that we left for you to load data, to make pretty prints, to load JSON, create directories, etc. And you have an empty train.py file. So you are going to set your Mlflow experiment and train code here. And the project structure is here. So inside ML folder, you have the data source. This is the base class, the database class. Obviously, everything is empty for you to code, okay? But just a structure to guide you through the process. And you have spreadsheets, if you have spreadsheets. If you have, for example, things in Spark, you can do another class to read it or something like that. Then you have the model folder with the metrics class. You have symmetric mean absolute percentage error, a custom score if you want to, mean absolute percentage error, regression analysis, a method to do cross validation. Anyway, so it's there. You have this trainer class that we talked about, and we left a trainer sklearn as an example to you. But the idea is that if you have another algorithms or another methods, you can implement a class like this, like trainer TensorFlow, trainer PyTorch, trainer CatBoost, whatever you like. And the wrapper, that is the object of the model after all the process is done. So you have the structure here. It contains the model itself, it contains the pre-processing, the matrix, the columns, and you have also when the model was run, when the experiment was run. And you have predict class, predict methods, save methods and stuff. This is there. And here you have a notebooks. I'm not going to open here in VS Code because I don't find it very attractive. But anyway, it's an example notebook. I can show you the implemented one in a bit. Then you have, sorry, pre-processing folder with the normalizer class. This is very useful in the projects. You have a pre-processing class. So you're going to build here all your pre-processing steps, and a text vectorizer if you are going to do some natural language processing stuff. Okay, and then at last you have these tests. Oh, I have already showed you that. Okay, so I'm going to show you an already implemented project.
Yeah, and I think one thing that this really it shows is that idea that you were going for, creating structure around your projects and making sure that things are clear so that if someone is the hero of a project and something happens to that person, then anybody else on the team can pick it up and know where things are and what is happening. And I think you've done that really well. You've been able to separate things and make sure that everything is very clear, so it standardizes the process.
Yeah, the main issue was that we have lots of people, and if we all use the same structure, the same idea for building the models, anyone can get to any point and help if you want. If we have to debug it, you know exactly where you are, and it's easy to debug. So I'm gonna just gonna get into our
what kind of project is this?
Our Connect. Oh, this is Titanic project, the famous Titanic model. We built a model. So here we have, I'm going to show you very quickly. You have the data here at raw, the train.csv. You have, let me show you. Okay, so first you have data source. We have spreadsheet implemented here. So it's just reading the data with the columns that we need, just to save some memory. Then we have pre-processing. Yeah, this is our pre-processing, a very simple pre-processing. We have a cleansing method that is cleaning, that is transforming, dropping NAs, dropping missing values, those kind of stuff. And we have a category encoding step here. Very, very simple project, just as an example. Then we have our trainer. So our trainer, this we didn't change. It's exactly the same trainer scikit-learn class that we have in the other, in the non-implemented version. Okay, so it already does cross-validation and stuff. And we have the wrapper. The wrapper is exactly the same. Okay, now what I want to show you is, we have the tests. This is very important. Okay, so if we want to do the test, we have to be in source tests folder, and you just type PyTest. We use PyTest. It does everything for you. We have 4 pass tests, some warnings. This is due to deprecation regarding some dependencies, but anyway, everything seems fine. So
we'll overlook those warnings for now.
Oh, sorry?
We'll overlook the warnings for now.
Oh, yeah. It's just, this is like deprecations of some dependencies that people have to fix. And then we have lots of tests of reading data, cleaning data, if the project is okay, if the category encoding is doing fine. Anyway, that's not a there is no recipe for you to do unit testing. It's in a data science project. This is very customizable, no? And you have the train, your main function here. Now the real deal, where everything comes together. So we have here I'm using a server that's in the cloud. And here I have all the steps. I read the data, I do the pre-processing, clean, category encoding. This is done in a notebook that I'm going to show you right away. Then we are testing 3 algorithms: random classifier, gradient boosting, and logistic regression, random forest classifier. And we are, I forgot who asked me about login. And here we set the experiment with the project's name, and when we are making our ML4 run, here we are logging the algorithms, we are logging all the metrics, and we have a function that gets all the metrics for you at once, and we log the module. So I have a MLflow server, it's in AWS right now. To run it, if you have this train.py file, you can just go Hermione train. She's going to look, I have to be in the right folder, to be in source folder. So you do Hermione train. Then she's going to train the model and save everything to, and log everything to MLflow. This should not take long. And then I'm going to start a Jupyter notebook just to show you the example notebook. It should not take long, but anyway. Okay, it's done. Obviously, we're not running MLflow locally, so you can ignore localhost. And then I have MLflow running here. So we have the Titanic project. We have built 3 models. We have some runs that I did before. So this is the 3 that we have just done right now. And for those of you who already know MLflow, this is good old MLflow. So you can get in here, compare your runs, see what's going on. Accuracy is not a very good metric to classification. I prefer F1 or AUC. Anyway, so it seems that, random forest gradient boosting is our winner. Anyway, so you can check these ones, and you have the models here. If you want to use MLflow already, a built-in API, you just register this model and do like one terminal command. It's very easy. And just to show you the last thing, I'm gonna show you Jupyter Lab. Oh, I have to conda deactivate because I don't have Jupyter Lab installed in this environment. And Jupyter Lab, okay. It should start in a bit.
There we go.
Yes.
So while we're waiting for Jupyter to spin up, if anybody has any questions, feel free to jump in or throw them in the chat. And
yes,
also,
please.
if you just want to let us know what you think of Hermione, give us some feedback, because this looks really cool to me. I think you're solving a lot of great problems that people have.
Thank you.
And yeah, it's very exciting. I imagine you put a lot of time into this.
Yeah, actually, as I said, it's not something that we decided one day that we would start building. It was born like for some years, project over project, making mistakes, learning from them, and gradually Hermione was made. This is the notebook that we left as an example for everyone. So we have in the beginning this. Extensions that we have if you want to use, like, for example, Plotly or those progress bars on TKDM, for example. We just made this as an example for you to do that. And also we have to change the system path for the structure to work. So when you're going from this point is on you. So in the not implemented version, code stops here. And the implemented, you have this example. So you're going to call your classes like this. ml.datasource.spreadsheet, you import the spreadsheet class and the preprocessing class and whatever. Then you get the data, check the columns, do the preprocessing part, and then prepare X and Y, do train test split, train your model, do predictions. This is everything that you just copy here and put in your train.py script, and then you make your predictions and test if it's going well and do test errors. We work a lot in Jupyter notebooks, Jupyter Labs. So this is just an example for you to structure your Jupyter notebook. So guys, this is Hermione. So that's it.
This is awesome.
We hope to get a lot of feedback from you of what you liked and what you didn't like so much. And we hope that with your help, we can improve this tool.
Yeah, totally. And if anybody wants to use it, the link is in the chat right now. We're also putting the link into Slack, into the Slack community that we've got.